All right. Good afternoon, everyone. Welcome. My name is Rushabh Lokhande. I'm Senior Data ML Engineer with AWS Professional Services, and I have my friend and colleague, Vivek. We are very excited to present in OpenSearch Con North America 2025 on the topic of building intelligent search systems with Agentic RAG and OpenSearch. So OpenSearch has quite a big role to play into the agentic flow, and you might have been attending a lot of sessions today. So we have pretty packed agenda to go through. So we are going to start with voice of customer and the challenges that industry has been facing, what we have seen on the ground, evolution of search itself. So some of it you might have seen, or if not, you will continue to see it over next 2 days, how search has evolved and it is helping the whole industry. Then we are going to go and change gears to Gen AI, so going from text to decision making, understanding some basic types of search, semantic, hybrid, keyword, etc., and then putting all that into action with an agentic flow in the demo. Right? So Vivek and myself, we work as part of professional services. So what we do is we work industry agnostic, going horizontally, not related to one business domain or such. So we understood, talking to multiple customers, that their challenges are about getting the critical information. Critical information is getting too hard. That's their key challenge. But this really started a decade or more back when the storage became very cheap and everybody wanted to store every piece of information. Amazon, being one of them, started collecting clickstream data. So they wanted to know what products users are adding in the cart, what are they removing, what are they purchasing, what is working out on the UI, UX versus not working. Just as an example, but there is tons and tons of data that started coming in. Fast forward to 2015, 2017 is when large warehouses came into picture, and there was no easy way to get the analytics out of it, where big data technologies like Spark came into play and started solving this for structured data. But alongside of it, there was one parallel track about the unstructured data, which was continuously growing. And we heard from the customers that 80% of the data in enterprise is unstructured. And that data is their intranet site, could be SharePoint, wiki pages, and very volatile, constantly changing, a lot of duplication there, not up to date. So 80% of the challenge is where customers started reporting their issues. We summarized them challenges into these 4 where we are going to focus. There are more, and you will see it in other presentations, but inaccurate keyword search. So user trying to ask for jacket, but getting only the jackets there. So it doesn't understand that coat is also in the umbrella of jackets. So keyword search got evolved into semantic search. We'll take examples of that. Complex implementations came like aggregation, sorting, reducing the performance of it. Manual tuning needed, scaling up, scaling down events when needed, and then eventually managing the maintenance of upgrading your cluster and keeping everything tight for your use case. Right? These challenges were then added up by the AI, which started like few years back, that your information is almost always out of date. So all the foundational models are trained on public data, and this keeps to changing. How many times we are going to train a foundational model, which is expensive, time-consuming, all of that, right? And then second part was missing your domain information. So if somebody's asking about what is the PTO policy for my organization, now it changes whether you're a full-time employee, part-time employee, you're a contractor, and it changes by the company itself. So that context was extremely important to be given to foundational model for it to make the right decision. And then because of the first 2 issues, the model starts hallucinating. Hallucinating is another big topic, but basically your AI is as good as your data. So that's kind of the challenge here. So OpenSearch, a community-driven approach, basically was one of the top search technology that came into play. And a lot of big techs that you can see here, AWS, Avian, Uber, SAP, started contributing to it. So I would strongly recommend you should check the roadmap, what is coming there. You will see a lot of it over the next few days. And OpenSearch really took that next step of doing analytics through vector databases, observability, visualization, all of that under one umbrella. In that effort, Amazon, and because we represent Amazon, there are other players as well, but Amazon solved some of these challenges by creating a managed service on top of it. And this managed service gave increased operational excellence, a managed scaling, your cost control, and the observability on top of it. Okay? But the evolution at the search level really went through these 4 steps, and you will see same or similar slide throughout multiple presentations here, right? So we really started with keyword search. You are trying to look for a quote, but a jacket doesn't come up. How do you solve that? Because that's a lexical model trying to do a keyword-specific search. So that was solved by semantic search. So you try to find a cosine similarity between the words and trying to put them into perspective and re-rank your data so that when you are looking for quote, you will also get jackets there, right? Hybrid search combined the capabilities of keyword and semantic search together. And then our today's focus is conversational search, because everybody is talking about, I don't need to know the syntax, I don't need to go anywhere. Can I do all of this through a natural language processing? So we will focus on conversational search quite a bit, which will use hybrid search, in turn which will use keyword and semantic search. And there are other sub-types of search like filter, sort, aggregation, many of those which are conventional open search capabilities. Yeah, and at the bottom of this is the progression of the models. So we are focusing on number 4, which is generative AI here. But let's take a look at one example of how search really evolved, and some examples which I'm sure all of you will be able to relate to. So let's go back a few years back. We go to wiki pages and search, where is my IT support desk? It used to throw you like 10, 15 different links, very generic, not specific to your location, not specific to your region. And then user has to go through these links one by one and find out the relevant information. With vector databases, you ask the same question and you will get exact or close to exact answer that the support desk is available on the first floor. So it turned from a conventional or a traditional search into intelligent search, right? The industry went one step further, which is where we are today, and this is still evolving as we speak, is generative search, which includes agentic flows as well. So let's take a look at this example. So here, there is a customer calling customer service about understanding what is my fire and earthquake coverage on my policy. So the customer assistant who is trying to help punches in that question, and then the summary comes here at the top. So it says, according to the underwriting guidelines, and then it also highlight what are those sources from which this information was taken. It says 80% of your property value should be your coverage. So for $800,000, it should be $640K. So we should recommend customers to add on $800 $640K coverage, which is going to add $950 per year, contributing to $80 per month in increase of their premium. So then this information is very crisp, summarized, aggregated, and contextualized to customer's question. And with that, when customer agrees to adding this, you can also invoke an action, yes, please prepare a policy and rewrite it with the client request by adding the coverage for earthquake and for fire coverage, right? So intelligent search came in here. It can not just search, summarize, or generate, but it can also take actions, which is referred to as agentic, another big topic to discuss. But an OpenSearch is playing a big role in this, but it is not limited to only a chatbot-like features. Really, the chatbots is now kind of old technology. 2 years back, people have been building chatbots in and out. But chatbot is improvising customer experiences for contact center analytics and giving internal and external chatbots. Then there are conversational search and text summarization for your productivity. There is insight generation using document processing and content moderation. And this will combine lot of ML, AI, and generative AI technologies together. So for example, you have a document for the policy, and you get a word from that document called a cell. Now, LLM foundational model without a context is not going to understand whether that cell is a physics cell, whether it is a biology body cell, or it's a prison cell. For it is cell is cell. So without we giving context, it's not going to make sense out of it. So that process is entitization. You give a word, a context, like 123 Fox Street, it's just in English natural language, but it is an address, is entitization of that. And that kind of capability come in document processing, content moderation, and then the whole new creativity aspect of image and video generation. So OpenSearch helps in lot of like wider spectrum of these use cases, right? But most of those use cases we saw on the previous slide can be broken into these three. There are more, and of course this is evolving, but it starts with prompting an LLM. You ask a question, get an answer back. But prompt engineering is a whole big topic where you can just ask a question, get an answer, or give an example. It's called few shot, one shot prompting. You give examples. If a question is asked in a certain way, this is how you should answer, and it will give you that answer back, right? Or you can do chain of thought or a combination of all these techniques together, right? So this one is simple question and answer, but then that got moved into RAG. And this is the topic we are going to discuss a little bit deeper, where user, along with a context and prompt, going on a vector database, tries to answer a user question. So RAG stands for Retrieval-Augmented Generation, and we are going to understand the basics of it right after this slide. But this is the second step of it, where you give your domain knowledge and more context to your chatbot, right? The third one is the agentic flow. This is where you will use the first two, prompting an LLM, give your domain knowledge, but also take an action. So that concept is called as tools. And tools in simple language is nothing but a function or an API call which does an action. So if you have unstructured data, which is PDFs and Word documents, but you want your employee information, their coverage information to be pulled from a database, that is where you will invoke a tool, which is API, in turn making a call to database, right? So let's double click on the RAG, as we said, because this is where our demo is going to focus more. So RAG has these two components, retrieval and augmentation, right? So retrieval will start from here. You get a document or set of documents from your document store, and then you vectorize it. But what is really vectorization? That process, and you might have heard this term embedding quite a bit. But embedding was evolved from encoding a few decades back when the conventional machine learning came. And encoding was a really simple concept. If you have a text, you assign, because machines understand only numbers, you assign a number to every word or token. So for example, text as vector, you will assign number 1 to text, 2 to as, and 3 to vector. But when corpus of your data becomes too large or too huge, then this kind of methodology doesn't work. And that is where embedding came into play. What does embedding do is it's going to put the semantically related words together. For example, a male, a prince, and a king are words which are put together, and they are assigned a number close by to them, eventually to plot them on X and Y axis. Little bit deeper concept, but simplistically, the meaningfully related words are combined together and they are stored here. So this process is done by an LLM, a type of LLM called as an embedding model. There are a lot of open source and proprietary embedding models which do this. That further gets break down into, is it a sentence embedding, is it a word embedding, and chunking strategies and logic, so on and so forth. But the idea in the retrieval is to get a document, vectorize it, and store it in your VectorDB, which is OpenSearch, Kendra, and a lot of other open source databases available there. But then starts the augmentation. which is where the foundational model comes into play one more time, where user will ask a question, and now, along with the question and the context from our vector database, the answer will be given. But this is where a lot of things happen. The question may not be forwarded as is. It will be appended to the context. Before appending to the context, the prompt may be rewritten. One question can be split into multiple questions, so on and so forth. But that helps foundational model or LLM to take better decision and give an answer back to user. Great. So in this architecture, you can see there is a document which we are using Amazon Titan, and we are creating a vector database, OpenSearch, and embedding that. So here, the source in this particular example is all the OpenSearch document, and then a user comes, he will ask a question to the LLM, and it will keep on building the chat history and respond to the question. So here are some examples, but in interest of time, instead of going deeper in here, we will see it with a Zillow-like example where real estate data is vectorized and how you can chat with it. But the concept of what you see in this purple box is slightly modified with Agentic RAG, where we are trying to embed the OpenSearch index itself and put the embedding on top of it instead of doing a whole document. So your data is already in OpenSearch index, but on every index with the property description, we are creating those embedding. So I will ask Vivek to walk us through the use case. But before that, maybe we'll cover a little bit basics about different types of search, which is extremely important to understand before we take a look at the demo. Thank you so much, Vivek.
Hello, everyone. My name is Vivek Gautam, and along with Rushabh, I work with AWS Professional Services. We help customers build data products, and I'm part of data and AI practice. I would like to thank my colleague Rushabh here. So I would like to thank my colleague Rushabh here for a wonderful explanation of how conversational search works and what RAG is. But let's take a step back. Let's try to, before we dive into the advanced capabilities of AI, let's try to understand the foundations, and that's where the keyword search comes into the picture. So how does keyword search works? It's basically a search which is used for an exact match. It uses a BM25 algorithm, which is a classic evolution of TD-IDF. And what that means is it depends on three things. So TD means TF-IDF, sorry. TF means term frequency. What term frequency is, how many times does the word that you're searching for occurs. So more the occurrence, highly valuable it is. At the same time, IDF, that is inverse document frequency, is trying to look for that particular word, how many times it had occurred across all the documents, like how rare is it. So again, more rare it is, again, it is valuable, right? And the third thing is the document length normalization, where if you have a longer document, BM25 prevents it from taking an unfair advantage by normalizing the document length. And so if you look at this example, this query is for the gaming headset. Does this work with my Xbox? And here the response is, does this work for Xbox One S, PS, or PS4, and the Lucent 6416D. You can see, since we're just looking for work on Xbox, it is just going to match with the first result, because it is going to look for the exact keywords here, Xbox and work, whereas PC, PS4 doesn't belong there, so it's not going to work. So some of the advantages of keyword search is basically fast, exact match, you know what you're looking for, but some of the limitations is these things are all similar, but it won't really work. So it won't understand the synonyms, it won't understand the context, it won't understand the intent, and that's where the semantic search comes into the picture. So let's understand the magic behind the semantic search, right? So again, the same question here, does this work with my Xbox? This is for the gaming headset. And here are the responses. Do they work with my Xbox One? Can I use this for the Xbox One? How do I use this headset with my Xbox One? And is this headset compatible with Xbox One S or above? So if you look at this, they are all talking about the same thing, but they are different words. So semantically, they are all the same, and that's why with the semantic search, you're getting all the results retrieved. And to get to a basic example here, if you look at hello, the hello has a vector embedding of 0.1, 0.52, 0.2, 0.3, 0.7, and then namaste, which means hello in Hindi, has a similar vector embedding, and then we have ni hao, which means hello in Chinese. We have set of vector embeddings. If you look at these vector embeddings very closely, you can see that all of those numbers are very similar, but the second element in here are a little different, but they're very close to each other. And that's where the semantic search looks for the Euclidean distance and the cosine distance, and then it basically calculates the elements close to it and basically it makes that semantic connection. So that's how the semantic search works. But now let's take an example of a hybrid search, which is where the evolution is, where a keyword search as well as the vector search can work in conjunction. So let's say, for example, sometimes you want semantic relationship, but you want an exact match. For example, if you're looking for iPhone 15 Pro Max, and if you're getting a result of iPhone 14, semantically they are very similar, but are they same? No. So you wanna understand how to use the hybrid search. So for this example, if you can see, here's the question again, the same question. This question goes through a lexical search with the BM25 scoring, as well as the vector search with the cosine similarity. And while there is a scoring that comes as an output of this step, these scores are normalized to the common scale, and then ultimately these scores are combined together using the formula x into BM25 plus y into cosine score. So now this x and y are weighted values, and where x means, like for example, if you have a e-commerce use case where you have your products, so you want to weigh in the value of x as a higher number than the value of y. But if you are a customer support agency and you're trying to make some semantic correlationship with the previous conversation, then your y value should be adjusted higher. And then the whole documents are re-ranked. And then if you look at this, all of these results are using the hybrid search. But then we also have a score here where does it work with the PC has a very lower score, but with Xbox One, and Xbox One S and above, they all are semantically very close to each other, so the scores are higher. So that's how the hybrid search works. And then I also want to talk a little bit about Strands agent. So since we are talking about this agentic flow, how did we build this agentic system? Was using Strands. So Strands is a open source Python SDK where building agents has become much more easier. It takes very less lines of code to build something, an agentic system now, instead of taking years and months of time. What happens with the Strands agent is it uses the, it depends on 4 things. First thing is execute, evaluate, and then execute, evaluate, and then again reiterate on top of it. So the first thing is, like for example, there's a question that you're asking, can you find me properties under $800,000 in the state of California with good school districts? So what Strands agent is going to help you with is, it is going to do a query to find the houses under $800,000 in the state of California, and then it basically starts to evaluate. If it answered everything, then it realizes, you know what, they're also asking me about the school district. It goes to a school database and tries to basically find properties near the school district. Then again it evaluates, and it keeps reiterating this until it gets the final output. And that's where the Strands agent comes into the picture, where it can hold the memory of the previous conversations and help you with the selection of the tool. With that, we have this Strands agent as a agentic loop. So like I said, the input comes in, then the Strands agent basically understands what needs to happen. It goes to LLM, it comes up with the reasoning that, hey, you know what, we need to answer this question with a school database. It would pick up a particular tool to answer the question, and it keeps reiterating until it has the final response. let's talk about the architecture before we get into the demo. So here I want to talk a little bit about the data set. So we're using a data set with the property prices, properties across United States where the data is coming from Zillow. It's a publicly available data set, and it has information about the address, location, prices, how many bedroom, how many bathrooms, tax information, and so on. So what we did is we built a Streamlit or an UI application, but we use Streamlit for this. And then it basically invokes when you ask a prompt, it invokes a API gateway, which invokes a Lambda function. Again, this is an AWS specific architecture, but this could be built on any other system. And that's where our Strands agentic flow runs, where we have 3 different tools, where we have a context tool. What this context tool is doing is, whenever you ask a question, it is trying to take that question and try to understand if there is any other questions that were asked in the past, and it tries to find references to it. And based on the references received, it basically comes up with an action plan. It passes the information to the query tool, and this query tool is basically trying to send information to the LLM with the prompt and the referential information, and it is trying to understand what kind of search strategy to be used here, whether it's a vector search or a keyword search or a hybrid search or a filter search. And then it creates a query, OpenSearch query, and executes that on OpenSearch, and it gets a response. The response gets passed on to the response tool. Response tool formats it in a way the question is being asked. And all of this information is stored in DynamoDB, where all the conversations can be retrieved by the context tool. So, and before that, if we can go to the OpenSearch, you need to press escape in the presentation. So we basically ingested this data into OpenSearch, and here we have the data in here where we have all of the property data. You can see the first example here where we use the power of OpenSearch to basically create all of these data. We created the content, and then we added the embeddings. There is a way to ingest this data into OpenSearch. There's a block for that. It's at the end of the slide. We can see that. And if you can minimize the embedding, I want to show there's like how the data set looks like. It has address, city, state, price. And so if you look at this, all of these attributes, they're all put together in the content, and then the embeddings are created accordingly. So with that, let's jump into the demo. So first thing first, we're going to ask a question to our system. Find me luxury properties in the state of Reno, in the city of Reno, Nevada, under $2 million. And while this is searching, what is happening under the hood is it is going to the context agent, context tool, and trying to see if there is any other questions asked in the past. If there's nothing asked, since it is the first question, there's nothing asked. So it comes up with a response. And if you can here, you can see that it came up with a property, 1735 Sharp Hill Drive, Sharp Hill Circle in Reno, Nevada at $1.898 million with 4-bed, 4-bath. And then it also said there is another property which is not in Reno, but a little further away in Pahrump, Nevada. And then their property price is $859,000 with 4-bed, 5-bath. And then it also shows you a semantically similar properties in the state of Nevada, again, Fernie, as well as Arizona and Maine. If you look at the search details, you look at this query is using a hybrid search, and it is using the vector embedding along with the keyword match, keyword search together. So this query is not written by me or not written by anyone else. It is what agent wrote the query. It executed the query. It got the response back, and it came up with the reasoning. It's a hybrid search. And if you go down a little bit, there's a session ID. If you can click on that session ID and go to DynamoDB here and paste the session and run this. So we are capturing all of this information, all of this conversation here. So we asked this question and we got a response here. So it's all being captured here. So back to the demo, we'll go to the second example, and we will run a second query. Find me such properties in the state of Wyoming. So again, such properties. So how does the agent know what properties? And again, the context tool is going back and trying to understand what questions were asked in the past. And it knew the question was about Reno, Nevada, properties under $2 million luxury properties. So it came up with the properties in Cheyenne, Wyoming. And then It also mentioned some of the other properties in Arizona and Hawaii. But if you look at the search details in here, you can see how the query changed from Reno, Nevada to luxury properties under $2 million in Wyoming. So it makes that semantic connection. And again, agent did this. Agent is smart enough to understand this. So all we did in the agentic application, where we educated our agent to basically look for such references. So it was smart enough to come. And again, the query was constructed by the agent. So let's go to the next example. Yeah. So show me properties near golf courses in Reno, Nevada. So this is a very interesting one. So we don't have any data about golf courses in our database. And maybe if it's in a description, that's possible. But we got some responses here that there's a property called 1735 Sharp Hill Circle in Reno, as well as some of the properties here with Ridge Lane, 6 Ridge Lane, as well as some of the properties on Desert Shadows Lane. So if you, we got the response, but we don't know if there are golf properties near these addresses, right? So what happened here? What happened is that agent and the LLMs made the semantic connection, and if you look at this hill circle, ridge lane, desert shadows, these are all the terms related to golf, and it made that semantic connection and tried to give you the answers. But is that the correct answer? We don't know, right? And how can we make sure these are the correct answers is basically we can onboard additional tools to our framework, where we could put a geospatial tool which could calculate a distance from each property to the golf course and tell me, hey, you know what, this is under 5 miles and this is probably closer to the property, or add a satellite imagery tool to the whole framework. So that's how the framework is scalable, and you can always onboard more tools if you need to. So that's another thing that became. And here you can see, again, it used a hybrid search, and it looked for show me the properties near golf course, Nevada. For the next example here, we have show me 3-bedroom houses under 500,000 in California. Well, finding a 3-bedroom house in California, I'm not sure if we might get a response, but let's see. And you know what? We did find a response in Lancaster, California. I wasn't expecting anything in San Jose for under $500,000, but yeah, we found something in Lancaster, right? So with that, if you look at the search query, so the question was pretty clear here. We wanted something under greater than 3-bedroom. So we have a filter here. We have less than $500,000. We have a filter here, and in the state of California. And if you look at this, we use the filter search in here. So again, the agent is smart enough to understand here this question could be answered using filter search, and it gave you the answer. And in the end, we have the last query here, where we're trying to basically find something exact. When we say something exact, it has to be a keyword search. And let's see if the agent is able to do a keyword search. And if you go to the query, it did create a query, and then it used a keyword search, and it got your response. And it's in Cascade, Idaho here on the top. So basically, this is how the system works, and agent is smart enough to figure these things out for us. With that, we'll wrap up the demo. If we can go back to the slides. So a little bit about us. We are part of AWS Professional Services, so we help customers build data products on AWS. So if you're struggling with any implementations, you can reach out to us. We specialize in OpenSearch. We specialize in everything analytics, as well as across AWS. So, and a few of the things that we have here is we have built this for many customers, so it's very fast for us to deploy anything for anyone who comes in here, right? So that's all we have. And with that, we have some time for questions. Anything else we want to showcase?
No, I think we have like about 3-4 minutes. Me and Vivek will hang out outside the room if there are more questions. But if there are a couple of questions, we can take maybe.
Sure.
Mike.
The example that you showed for the agency.
Yeah.
So the example for agents, one of the actions that happened is an OpenSearch query that the agent fires on query coming from for the agent to be able to perform a very syntactically correct query
Right.
to OpenSearch?
Right. Right. That's a very good question. So let me show you a little bit what is happening behind the scenes. So this is where we built our solution, and this is where all our code is. So if you look at the prompt here, so for the context tool, it is basically trying to, we've given a prompt to the agent. Hey, you know what? When you're looking for such properties, resolve to referential integrity, right? And these are some of the examples that we have given. So we are educating our, for example, this is where the queries are available, right? So here's the prompt. Based on the conversation context, determine the best search strategy. And we have educated our LLM to basically use this. And that's how it determines. So we spend time to educate the agent so that it could come up with the strategy as well as the how you would come up with the query and query it against OpenSearch.
Yeah, go ahead, please.
Thanks for the great presentation. Really appreciate the clarity of the diagrams and how to build these systems. There's complexity there, right? You have packet search, you got the embeddings, you're talking about strands. Curious, like as you're working with customers, when you're trying to evaluate the solution, so you need to change one of those pieces. How are you evaluating? How are you determining, which part of that flow needs to change in order to be interjected?
So the whole framework that we've built here is very loosely coupled, right? So right now we're executing this code in Lambda. That's where the whole logic resides, right? This can work on any other cloud provider or any other on-prem data centers, right? In terms of using strands, yes, this could work with LangChain, this could work with LangGraph. It's just an option. We've used this just to showcase the capabilities, but anything here can be replaced with whatever your company or your organization is, the tech stack that they have adopted. Does that answer your question?
A bit, but do you have a base practice or a recommendation for evaluating?
Yes, so there is a framework, right? And agentic flows or systems are slightly different than other applications we build, microservices and everything, right? So remember there was a slide where it goes through prompts. So prompting is one of the part. A lot of things can be prompted to your agent through your prompt. There is a concept of prompt cataloging. So you're asking a question in different language, like properties in San Jose. Give me properties in San Jose. Are there any properties in San Jose? So semantically same questions, finding cosine similarity and creating that crisp question that your LLM or agent understand. That's step one. Step two is giving your knowledge base or domain knowledge to it into that context, correct? So prompting, then giving a RAG, and then giving the tool set for the agent to do it. And that tool set at times may not be sufficient to be done by one agent. So there are concepts like multi-agent collaboration. So in a big organization, like there is an order agent, there is a customer support agent, and there is supply chain agent, and there is the orchestrator sitting on top of it. So this is also kind of design and build in a microservice way, and a combination of multiple such concepts. Would be happy to talk after that in detail after the session. Yeah.
Yeah, I have a quick question. So you mentioned like in the prompt, you have to queries and respective queries as well, but those requires more lagging as well. Like if you are performing a vector search or it requires a text search function. So how are you passing that in the context of the LLM?
So that's why we're using this agentic frameworks like strands. In strands, you could pass on what model that you want to use against LLM.
So are the tools and the strands related to open source or those
Tools are, so the tools are that you can use either inbuilt tools, but our use case was very custom. So we built our own custom logic based on what information needs to be passed on to LLMs to make a decision. And the logic was in the tools that was being referred. And with the power of LLM and what the tool was supplying, it was smart enough to basically make a decision.
So you're building your own custom.
Yes.
Yeah.
Are this publicly available?
We will, not right now, but we will make it publicly available.
Correct. Yeah, because we are looking only at the front AI part of it. There is a data pipeline concept of creating this data foundation for AI, which run behind the scene. So when we got this data source, we have run it through vector model to embed and create those embeddings onto the index. And then agent with the tools is responding to that. Yeah.
Right.
So with that, thanks so much, everyone.